water block factory near Berlin in Germany produces some of the highest precision water cooling blocks in the world.
And you can see it is 0.2 millimeter thin. We also have 0.1, so we're currently, to my knowledge, the only water cooling company that is able to do 0.1 millimeter slots.
And it's helmed by Roman, aka Der8auer, from Thermal Grizzly, the same company we visited previously to see how thermal paste is made by the kilogram and how liquid metal is made by the syringe. Last time, Der8auer warned us about explosive chemicals and exposure to air for liquid metal manufacturing.
That is quite interesting in a term of that if you expose it to air, it can self-ignite.
Cool.
Yeah.
Can we try it?
No. It can get warm, it produces hydrogen, it can explode. Yeah.
I feel like everything you deal with is either dangerous or it looks questionable. This time, he warned us about explosive tanks for his CNC shop.
Then we have this huge tank where we hope it just never blows up. It's 3,000 liters, 10 bars. It always feels a bit odd standing next to things like that.
We wouldn't know.
Yeah. The cool thing about this is hopefully.
In this factory walkthrough, we learned about the highly automated processes that minimize the amount of people time involved in manufacturing, which enables Thermal Grizzly to self-manufacture a lot of its moderate volume products in Germany.
It's again a lot of machine time, almost no time for people.
Yeah.
Because there's no other way we can manufacture anything in Germany. It's just not possible.
As part of this tour, we got to see something that, at the time, Roman hadn't yet launched, which is his new bench table. We got to see some of the early decision making of it. This CNC shop deep dive is part of our Made in Germany series of factory tours, with just one left in the series after this one. Why don't you present it? It's your product.
Nice acrylic block. Please buy, thanks. Made in Germany, yeah.
Let's take a look at the Thermal Grizzly machine shop. Bevor es losgeht, dieses Video wird euch präsentiert vom Heatsink Touch Infinite. Jetzt erhältlich beim offiziellen Heat-Partner alternate.de. Wir haben das Heatsink bereits getestet und fanden die Verarbeitungsqualität konkurrenzfähig. Besonders die Materialien des Gehäuses haben überzeugt. Das Gehäuse wird jetzt mit einem individuell gestalteten Touchscreen geliefert, mit dem ihr unter anderem die CPU-Temperatur anzeigen, Spiele spielen und vieles mehr machen könnt. Die Y70 von Heat ist jetzt außerdem in zusätzlichen Farben erhältlich. Mehr Infos findet ihr über den Link in der Videobeschreibung unten. Zurück zum Video und danke, Heat und alternate.de. Where are we going now?
We're heading over to the CNC milling machines where we're making water blocks. The direct die blocks, mainly heat spreaders, contact frames. This is where it basically starts on this machine. So it's just cutting the entire plate down into the shape first. That's where we do the top side of the water block. So it's the same parts, flipped around, put into this vacuum holder, and then just the top surface is milled.
Oh yeah.
It's getting rid of the leftovers first. This was our first CNC. We still use it today. Yeah, we have this. It's an ironing air gun.
Okay. Immer geschlossen halten.
Yeah, it's because you're not supposed to walk in here. Now we're moving into the mechanical side of things, where we are currently working on sheet metal stuff for our bench table we're working on.
Yeah.
This area here on the right, we have a water jet cutter, and as you see by the warning sign, that is in German. The first line says that it's with a water pressure of 4,136 bars.
Okay.
Coming out of that pump that you can see there, that consumes about 40 kilowatts.
Wow.
Yeah, that is the number above like
40.37
kilowatts.
Okay.
Constant power consumption.
Yeah.
Here we have Oliver, who is one of our engineers, and he's working on that topic right now. So he's programming the machine and making sure that everything is cut out and then later on bent to shape.
Okay, cool. So what are you cutting on this?
Today we're gonna start with some pieces for the bench table. We got aluminum here.
Okay.
It's just a thickness of 3 millimeters. We're gonna do today, but usually we do aluminum or glass, for example. Whatever thickness you like. We could actually do up to like 10 millimeters.
Oh wow!
Just import it from the drawing, and then put it on the machine and it pretty much reads by itself. And
what actually is this? This is a leg for the bench table?
yeah,
or?
correct.
Okay.
No, this is the bracket for the part behind behind the bench table.
Yeah.
Yeah, sure. So we cut it up first, and then later on we're gonna bend it, so it will actually get the shape we actually see in the end.
Okay.
As you can see, we already put the material in. We just fixed it a little bit so it won't change the position.
What is important to know is that it's actually not the water that is cutting, but there's an abrasive material that you can see on the left, this sand-looking stuff.
Up there.
Exactly. That is injected through the pipe onto the nozzle in the front. And it's kind of like grinding. It's more like a grinding process. So you have the water that carries this abrasive material, and then this cuts away anything.
All right, so let's start the pump. There it goes.
For this product, how long does it take to actually cut everything?
This cutting is just like 40 seconds. As you can see on the display now, we're on part 3. We're done with cutting. I'll just turn off the pump in the back. Pretty much lower the barrier, so. This is our first part.
Is it okay
Just,
to touch?
yeah, sure.
All
It's
right.
just normal water, and it shouldn't be that sharp on the edges anymore. That's
Nice.
one positive part about water jet cutting. We will go over to the bending machine, and we'll have a look if we can get it into the right angle, I guess.
Okay. I'm guessing by the name, this a Boschert Profi 28 CNC.
Yeah, correct.
Which country do you think it comes from?
I'm gonna go with Germany.
We got the program for that ready here. The angle needs to be 100 degrees. I will just place it on here.
Cool.
Yeah. So that's pretty much it.
Seems pretty self-explanatory, right? So I don't know what kind of volume you're doing, but once you kind of go to, I'll call it mass production. I don't know if that's
Yeah, we will
correct or
do 1,000 pieces initially.
not. Okay. So will all of that go through this specific machine,
I'm not sure yet.
or is this like a prototyping? You know?
Like right now, we're still in the prototyping phase, and we still have to figure out some things, you know, about the plate, some holes, and
Because if you end up liking the product, I mean, I guess I'm mostly just curious. Do you end up making them all here through your own machines, or do you?
it could be that we
Offshore it.
that we outsource some
Right.
part of it. It will depend on the demand mainly. The big advantage of having the own machinery is that we can just make 100 pieces.
Yeah.
And it will basically cost us the same as doing 1,000 pieces.
Right.
So we are not tied to any big MOQ.
Yeah.
And if we see, I mean, let's say there's a demand for 10,000 pieces, we will not be able to make this here. Then we will have to find a partner to make it with. Yeah, it's
That
pretty
makes
simple.
sense. Where are we going now?
We're heading over to the CNC milling machines where we're making water blocks. So the direct die blocks, mainly heat spreaders, contact frames. This is where it basically starts on this machine for at least this one demo that we're doing today, which will be an AMD Micro Direct Die Pro, we call it. So that's the latest and best performing direct die block that we have for AMD. And it starts by placing this big piece of copper there. We always work with plate material. That is different to most of the other machine shops you will see, especially if you go to China. They have smaller machines and they have a lot of people handling them. What we're trying to do is be very efficient when it comes to people. So we have more machines that have much more room.
But fewer people.
And a lot fewer people.
Right.
So we can have, let's say, 4 machines can be operated by one guy.
Right, okay, cool. Yeah.
Du kannst schon starten. Copper plate is placed on the vacuum table. So what you see there, this white stuff, that is a vacuum table on the bottom.
Got it. Okay.
That keeps down the copper plate. And now the first step before any of the stuff is milled is that we have like a bigger end mill that was measured in height, and now we're getting the plate into the final height. So it's just cutting the entire plate down into the shape first. Ultimately, the plate that you see there comes out like this. It will still stick together as a plate. There's still a little bit of, I'm actually supposed to only touch this with gloves. There's a rule that I established that you can only touch it with gloves, but here we are. And you can see there's still a tiny bit of copper left.
Yeah.
That keeps them together. Then we cut it with a knife, and that's the first stage of the water block. That is the contact area right here for making contact with a die. But what we do now is, before we move over to make the top side, is we have to quality check these, especially for any direct die cooling. We just learned, from mistakes as well, that you have to control the height of everything, like precisely. Otherwise, people will have contact issues, will have bad temperatures.
I guess it becomes, at a big scale, it becomes an opportunity cost, right? Like, how long does it take me to make this thing versus this other thing?
The thing is, we're constantly, or currently, we're not limited by the machine time.
Okay.
In terms of like our production capability, it is more because we don't have enough manpower to fully always use all the machines.
Okay.
And that's why the machining time is currently not that relevant. Usually they already prepared it, so we take 3 pieces out of them and then we measure them. Okay. So that's what we do in the room next to us. And this machine I already showed a couple of times in some of my YouTube videos, because apart from in the daily use, we just use it for quality check of the production.
Yeah.
The cool thing about this is that you just press measure and does everything by itself.
What's sort of the precision, I guess, of the machine?
This machine can read up to 0.2 micrometers.
Okay, cool.
It's quite accurate.
Yeah, that's cool.
If we click on here, then you can also see all the individual measurements that were taken. So we see the flatness, we see the height difference from each of the PCB contact points to the center, and like roundness, whatever we need.
Right.
It's different from block to block. Yeah. It is a similar machine, just slightly different shape, a little bit smaller, and that's where we do the top side of the water block. So it's the same parts, flipped around, put into this vacuum holder, and then just the top surface is milled.
Oh yeah.
It's getting rid of the leftovers first. We can probably make use of our time, move over here. This was our first CNC. We still use it today. It is just much less powerful than the others.
Okay.
But it's still very good for making or for milling any kind of plastic. And that's what it's doing right now. It's the acrylic cover that goes into the water block.
So is all the snow just acrylic, basically?
And that's all the chips from the acrylic.
Okay, yeah.
You can see this together. It takes like probably 5 hours for the entire plate, but it's 5 hours of nobody doing anything. It's an ironing air gun.
Okay.
Without this, you can see that all the acrylic, it sticks to all the surfaces. And with the iron gun, if you point towards it, it falls down.
Cool.
Which is helpful, but it's still a mess. It's still a mess.
Made in Germany.
Made in Germany, yeah. And the warehouse is not that interesting, but just to have
People always say that. It's context.
Warehouse is a lot colder.
Immer geschlossen halten.
Yeah, it's because you're not supposed to walk in here, or at least keep the door open. We can walk in, but not keep the door open. This is the sound blasting.
Okay.
Technically, it's the glass bead blasting, because we're using glass beads instead of sand, which is much finer. So it says only for authorized personnel, but I guess we are.
Wow, okay, cool.
Yeah, that's...
See, this is like, people always say it's not interesting.
Yeah.
It's super interesting.
I mean, it's kind of interesting. One of these is 22 kilowatts in power consumption. They're not running full time all the time. The point is that we have two, so one of them can run, the other one is not doing anything, and then they're switching around.
Are these for the whole building or just for the...
Yeah, it's just all the air that we need for the machines mainly.
Yeah.
Every single CNC needs it. The glass bead blasting needs a lot of air. pressure testing, whatever. The SEM needs air.
Right.
So all of those machines, they need clean air as well. So that's what these are for. This is for getting rid of moisture.
Oh, so is this what I was seeing everywhere, these blue pipes? Okay.
This is just the
now it makes sense.
pressured air supply.
Got it.
So first it's filtered from getting moisture out. That's why these chillers are used. You can see 3 degrees. And then this one is for getting all the oil out of the system.
Okay.
Then we have this huge tank where we hope it just never blows up. It's 3,000 liters, 10 bars. It always feels a bit odd standing next to things like that.
We wouldn't know.
Yeah. The cool thing about this, hopefully. But the cool thing about this room is that we are reusing the energy that is generated in terms of heat from the compressors. So they are connected over this system right here.
So you mean these themselves, the heat from these?
Yeah, the heat from the compressors, they're not just put outside, right? Yeah. It is, there's a heat exchanger in here. This one you can see the plate heat exchanger. Yeah. And this exchanges the heat to the building. Okay. So we are heating our building with the wasted energy of our compressors.
And at 22 kilowatts?
Each.
That seems like a lot of heat. Do you need a traditional heating system if you would do this?
Yeah.
Still, okay.
Yeah, because they're not running on full load all the time.
So you needed to smooth it over.
Yeah, but it's still enough to just get like a base level.
Is this your advanced insulation system? Did that Atlas Copco install it?
It's a sunroof.
Oh, is it? Okay.
The problem is that we are still in the renovating phase, and we only have sun shields on first and second floor, and not on the ground floor yet. And if you're here, especially now in winter, it's fine.
Bake, I guess.
In summer, there's also no AC in this room. Yeah. And you can imagine if it's like 30 degrees outside and the sun is like.
Right.
This is like, I think this is the most hated place or room to work. What is kind of interesting is our contact frame fixture. So each contact frame that we make at a certain point lands on here, and then just being stacked, and then somebody by hand sandblasts them, glass bead blasts them. And what I find interesting is how much of this original plate is gone. Like this is just the negative that is left, because this is already all taken away.
Right.
And I think this has seen maybe 30 to 40,000 contact frames.
Jeez.
So maybe you have to oil it at some point. Yeah, and then you can go in, and then you have the hose with where it comes out.
Oh yeah.
Yeah, and then you stand here and go through.
Is this by design? I don't know if that's a maintenance item for you. You see what I'm talking about, right? Like, but that one's doing it too. I mean, it's not my problem. I don't care.
Thanks. This is also where we store all the materials that we need for milling. There's a bunch of aluminium stacked, white water blocks, covers, different types of aluminium. That is.
Wow, is that just copper?
That is copper for upcoming GPU water blocks.
Cool.
But I think the raw material cost for the block will be over $100, just the raw material without even doing anything.
So no machine time, no engineering or R&D. The warehouse was interesting. You undersold it.
This is the typical place where you just don't look. Actually, I don't even know what's inside.
Ratchet and Clank is in here. The game right there, PlayStation 5.
What the hell?
You're welcome. Now you know you have it.
I never in my life owned a PlayStation or any console, so I'm not sure where this comes from.
Someone probably just dumped it, I guess.
There's even a controller.
You might have a whole PlayStation in there. I see the base for it.
Oh wait, yeah. I totally forgot about it. We were making PS5 blocks. Yeah.
It would make a nice, like a nice studio apartment.
That's usually where I live,
Yeah.
Now basically the top part will be done of these pieces, and then we get them out, and then we move over to our 5-axis milling machine to make the water cooling channels.
And so this is like 30 minutes worth of milling, I guess, or cut it, whatever the phrase is. But
yeah, I think overall, if you would calculate it, every single block takes about 10 minutes for just pure manufacturing time.
Yeah, very
so
shiny.
You were asking about the surface that we're making with that diamond cutter.
Yeah.
And those are Intel heat spreaders. And the top surface is diamond milled. So
Wow.
it's like perfectly shiny.
But
that's AMD.
Yeah.
And it's essentially the same as the water block, just without destruction, and you can mount a cooler on it.
What's like the split Intel to AMD for your customers?
It used to be a lot more Intel, but now that Ryzen 9000 is overclockable, well, 9800 XTD, the demand increased drastically. Yeah.
So like percentage-wise,
right now I would say it's 75% AMD.
wow. All right.
Yeah, that is contact frame manufacturing. As I told you, we are also running plate material here. The base plate material here is 6 millimeters. And then we're getting 56 pieces out of it.
Wow.
It's done in essentially 3 operations. So first we're drilling some holes into the plate. Then we're doing one side, flip it around. And this is now the third and last operation, where all the contact frames are being milled. Yeah. And if you're now looking at what we're doing, this is why we can't sell a contact frame for $5, obviously.
Yeah.
That is the second step. So after the drilling, first side and then turn around. And then it looks like this.
Wow, okay.
Then we add, in every single one, we have to add a small fixture that it is held down in the center. It's those small blocks. So every single one is held down, and then it's being cut out.
How long does it take to do one sheet like this?
5 hours.
Wow.
It's again a lot of machine time, almost no time for people.
Yeah.
Because there's no other way we can manufacture anything in Germany. It's just not possible. That is the most expensive milling machine that we have. It's a 5-axis machine that I would say 90% of the time use for the slotting operation. That is mainly because of the stability of the machine, because the tool is very fragile. Currently, we are using this tool, and you can see it is 0.2 millimeter thin. We also have 0.1, so we're currently, to my knowledge, the only water cooling company that is able to do 0.1 millimeter slots. Currently, we're developing an AM5 block that will be at least from the current testing, the highest performing AM5 block in the world. And it has 134 cuts.
Okay.
So we can do 10 cold plates with the one tool.
Yeah.
And if the tool costs, let's say, $400, then just the cutting operation will cost $40.
Right.
On the cold plate.
Split across the units you end up making. That's crazy to me. So is it, when you say tool also, is it literally just this piece?
It's just this piece in the front.
And that might be $300 or $400?
Yeah.
Crazy.
Yeah. What we want to create is what we call a hybrid structure that's for AMD. And in this area, we will have the CCDs. So very dense, high surface area.
Right.
And I mean, here where the, how's it called, the IO die is sitting, we just need a lot less cooling.
IO die is not that hot. And if you did the higher density over everything, is just cost is insane or what?
It just doesn't help the CCDs, like no difference.
Right.
And I mean, we're basically paying per cut, kind of, right?
So you use them wisely, right?
Yeah. If you think about how small this is absolutely crazy in terms of how quick it cuts. So we need Florian again for laser engraving.
Okay.
We add a serial number on every single block. As far as I know, we're also the only ones who add serial numbers to water blocks. But for us, it helps to track down our own mistakes.
Yeah, no, that's good.
Yeah, so on the right, we have micro, then it's basically the year, the calendar week.
Right.
And then it's a different label for what kind of product and so on. Wir können jetzt hoch in... Bist du die Letzte? Okay. Here we are in assembly, and because it's 7 p.m., there's only Cora left that will guide us through one piece of water blocks.
It's not actually 7 p.m. He's just saying that nobody works here. It's actually only Roman.
I have proof. So after we get all the individual parts, so the acrylic part that you can see on there, after the milling downstairs, it is getting cleaned and it's getting tempered. That's also a step that we skipped. But it usually spends 1 day in a tempering oven.
Prevent cracking, I guess?
Prevent cracking, yeah. Especially long-term aging, you would have cracks at a certain time. Then we have the O-ring that is being placed. Then we get the jet plate. It's also a piece that's milled.
Okay. The torque driver, I guess?
Yeah. So on the bottom of the water block, we also place this insulator sheet. And this is mainly to protect the motherboard.
Cool.
Yeah, that's how the water block is assembled.
Nice.
And after this, it is being tested. If you pressure test, it's like there will always be a leak. It's because the gas, it can work its way through the O-ring. It's just a question of how leak-proof is it.
Right.
And that's the number we're getting.
So you have, I guess it's the serial number and then the actual number of the result. Okay.
Yeah, so it's just getting closed off and then...
So there's 0.6.
Yeah, it just takes, initially it's filling. At the same time, they're also testing if the RGB strip works. Stabilization time, that there's like no big fluctuation. You can see there, this again in Pascal, which is 0.001 millibar, I think. It's already really low.
So it's counting down the test time. Okay.
Yeah, so after I think it was 15 seconds, it's minus 27 Pascal that was lost, which is within our tolerance that we determine as leak-proof.
Okay.
And then, yeah, the result is written on the pressure test protocol, noted down in our system.
And then serial numbers logged for the user, I guess.
Yeah.
Cool. Very efficient.
So if there was a fingerprint on it, it's in the end now getting cleaned anyway,
right.
So you won't see anything of that.
Roman has handed me off to Joe. So what's going on here?
So we tried to put together a really concise range of fittings. So we don't have many sizes, we don't have many options, but with them you can build up a lot of combinations of things. So the most unique one is the 90-degree fitting, which at first sight, it's like it has no base, right?
Right.
Normally they have like a nulled section which you can grip it with. And our original idea was to make that in different lengths so you could change how big the fitting was. And then coming up with mechanical concepts for that, we decided to remove it completely, have just thread here, and then you screw it in with a hex key.
Oh, okay.
And you can attach it to then any other male-female extender to make it as big as you want it to be.
So this is SolidWorks, I guess?
Yeah.
Do you do the actual, effectively CAD in here, like the actual mechanical design of everything?
Yeah. So it's very good for parametrically defining things, and if you want to have like lots of configurations to the same thing, and if you use a lot of common parts and adapt things. So like this drawing, it has this is the assembly, and it has both the T-fitting and 90-degree fitting inside are defined from the same part.
What is the what does it look like when you're actually doing the design, and like how does the interface change?
This is like the first sketch of the first part of the model.
Okay.
And then it just has a few finishing steps, but not many, just like the slot cuts from the side and the hexagons and stuff like that aren't round.
I guess basically, do you take the approach of I'm going to make the thing I want and figure out the manufacturing later? Do you think about it the whole time you're working on it?
I mean, definitely, like if you want to achieve a certain quality of finish and you want it to look really precise in the end, you can't ignore how it's going to be made at any point. And having the knowledge of how it's going to be assembled, how it's going to be made throughout is important. And it's just a case of not overburdening our machining capacity.
Okay.
If we decided like simultaneously to make CPU blocks, GPU blocks, distro plates that are all really intense milling, then we'll instantly need...
You need to outsource or you need to stop one of the projects, I guess.
Yeah, I mean, I can show you this prototype, which maybe Joe wants to give his personal opinion on my pump reservoir design.
This is Roman's
industrial
design.
I made that on a weekend. What did you say, Joe?
Yeah, it's the who can use the most machine time competition, I think.
He said this is the most expensive way to make a pump reservoir combination.
Okay. What makes it so expensive to make?
This is all one, except for the bottom, it's all one piece. Like this is all one piece. And so it's milled on the five-axis machine from different angles.
So you basically make one at a time?
Yeah,
you can't make all the pieces.
No,
and
you
then
just can't make one.
Okay.
And what is kind of special is this is glass.
Okay.
So this is also cut on the water jet cutter downstairs. I mean, I just like, glass, and maybe it will stay one out of one. I'm not sure yet. But I like the design. Maybe I will just do it for the sake of doing it.
Do you know what the actual sort of time would be? Like if you had to estimate it?
We checked manufacturing time, and just the core was 48 minutes for one piece.
Holy crap.
And then it's the other few pieces, so I would say it's about like 1.5 hours for one piece.
Mm.
We can make it easier. We can make it a lot easier.
So that's an interesting discussion though. So like, Joe, with your experience, when you look at this, you're trying to figure out how do I make this a thing that we can actually sell for less than $1,000.
I was about to say we can sell it, but I think nobody will like the price.
Yeah. So where do you start? Like if he hands you this and says this is what my idea is.
Typically, it's how can I use bigger diameter tools to make it, because they'll run much faster and you don't have to worry about stressing the machine or the part vibrating as much, which was a problem for this. And how can you reduce how many operations you need to make it? And if you can eliminate entire parts, that also makes a big difference. Or make lots of parts the same part, which I think all three of the windows are the same, and the three little frames which hold them. So that's a good start. But the block in the middle, it's milled from every side, all six. Okay. And when it's from the top, the tool's coming all the way inside to drill that hole in the bottom.
Okay.
Yeah, come on. I thought it's 5-axis machine, so we have to make use of all the axes, right?
Yeah, everyone.
He paid for 5, he's going to use all 5. That's it for our tour of Thermal Grizzly's factories. In our previous 2 installments of this series, we looked at the liquid metal manufacturing and at the thermal paste manufacturing. Those 2 videos ended up being some of the most detailed in terms of the process information you can find on the internet. So we'd recommend checking those out if you want to learn more. As always, we fully fund our own trips for this kind of content. The goal is educational content that you can't really get elsewhere in terms of the level of access that we gain. A lot of that is because we control the full process. Our thanks to Roman from Thermal Grizzly for letting us basically just do whatever we wanted and walk around freely in the factory. And as always, if you want to help support this type of content and our travel for this type of content, which we fully self-fund, you can go to store.gamersnexus.net. Thanks for watching. Hopefully you learned something in this educational series, and check back for more. We'll see you all next time.